MongoDB in C# and .NET Core. Introduction. This lesson will discuss BSON objects and how to map them to a C# object. It will also introduce a database and its C# equivalent, which we will use for learning purposes. We'll cover the following: mapping BSON to strongly typed C# object, example database, C# equivalent, explanation, recap. In previous chapters, MongoDB Basics Part 1 and Part 2, we covered some of the foundations of this database. We learned how to create databases, collections, documents, and we learned how to use them. We also learned information about distributing MongoDB, shards, replica sets, and how to manipulate each of these entities. Nevertheless, there is no single line of code, and everything is explained in a general manner, more or less. MongoDB shell client was used to demonstrate all of the crucial operations, so readers were not exposed to any coding lessons. That is why, here, we'll try to show you how MongoDB can be used, in the code, to automatically do some of the operations shown in the previous lessons. So, let's take a look at how MongoDB can be used in .NET by implementing a simple MongoDB CRUD repository. Mapping BSON to strongly typed C# object. If you have read the previous chapters, you will have learned that MongoDB stores documents in BSONformat, which are basically binary JSON files. Okay, it is a little bit more complicated than that. When we use .NET driver, we consume documents through BsonDocument. What we want to do in this exercise is to map those BsonDocuments to strongly typed C# objects. But before that, let's see what our database and its entities look like. Example database. For the purpose of this exercise, we will use a database called blog. This database has a collection, users, which contains a document for each user. The JSON document for an individual user would look like something like this.
So this JSON object look like ID, name, block, age, and location. This is a BJSON, it's a binary JSON file, and this is the C# equivalent code. So the C# equivalent code, we are importing MongoDB BSON, MongoDB BSON serialization attributes, and then getter and setter for the ID, name, block, age, location.
Create and read operations. This lesson teaches how to create the class used to access MongoDB and the methods to perform the basic CRUD operations as C#. We'll cover the following: users repository, create users, implementation, read users, implementation, users repository. The goal of this lesson is to create a class which will give us the ability to do simple CRUD operations on the users collection. The first thing we need to do is connect to the database from our application. The easiest way to do this is by using the Mongo client class, available via the MongoDB driver that has already been installed for you. Its constructor requires a connection string, which we will provide. Alternatively, Mongo client settings class, available via the MongoDB driver, can be used as it provides various possibilities. One such possibility is the cluster configuration property, which is of the cluster builder type and used for configuring clusters. Other classes that we need to use are Mongo database, to access defined databases, blog in this case.
So the blog in this case, Mongo collection is access defined the users. This is class. So you can see the client database, user collection, the user information.
This case, and Mongo collection, to access defined collections, users in this case. There are three different.
So you can see the create user, so user collection and insert user by, and implementation, insert user, the implementation is this code, and read user implementation is this code. After the video you can pause and read this code.
Three different implementations of this functionality. Let's go through each of them. In line 1, function getAllUsers returns all users from the database. We use the find method, line 3, of the Mongo collection class to do so and pass the empty BsonDocument into it. In the next method, getUsersByField method, line 6, we can see that the find method, line 9, actually receives the filter object, line 8, which it will use as a criterion for getting the data. In the first function, line 1, we use an empty filter and thus receive all users from the collection. In the second function, line 8, we use builder to create the filter which will be used against the database. Finally, the last function, getUsers, line 14, uses skip and limit methods, lines 17 and 18, of Mongo collection to get a necessary chunk of data. This last function can be used for paging. Implementation. Now, let's look at the executable code for the three read users functions discussed above.
So this is the suitable MongoDB system, collection, generics, thread, toss, length, and all this information, and update, delete, index operations. Let's talk about this one.
The output of this executable will be displayed in the Terminal tab. Update, delete, and index operations. This lesson will teach you how to perform the update and delete user operations in C#. It will also teach you how to create indexes. We'll cover the following: update users, implementation, delete users, implementation, creating indexes. Conclusion. In the previous lesson, we looked at how the basic CRUD operations, create and read, could be performed using C#.
So this is the update user. Update user we use like user collection update, one async filter and updates, and is a
in C#. Let's learn about some more of them below. Update users. Documents can be updated in a similar manner. Testing CRUD functions. In this lesson, the whole project will.
So we are talking about update users and then get user field by name, first or default, MongoDB user update, address and test address. And delete user, there is also option called delete many async, delete many async collection is delete not equal to 0. So there is the delete task, and then implementation is here, creating index is also here.
Will be compiled to test all the functions discussed in the previous lessons. We'll cover the following: running the test file. In the previous lessons, you saw the implementation for the create, read, update, and delete operations. In this lesson, we will test these functions by running the test case file, mongodb.dll, that is created when the GitHub project compiles. All the test cases should pass if the implementations are correct. You can go through the file MongoDB repository tests.cs, given below, in order to.
So this is the test file and all the things we can test here. So thank you for watching. Please like and subscribe. This is video. So next coming lecture I am going for MongoDB in details.